Hello Linux enthusiasts! Welcome to our tutorial on mastering directory permissions. In this tutorial, we're diving into the basics of directory permissions, understanding and changing directory permissions, and special permissions like the sticky bit and set GID flag. Let's get started. Let's begin with the basics of directory permissions in Linux. Directory permissions are fundamental in Linux, controlling access to files and subdirectories. The command ls-ld lists the information about the directory without listing the contents of the directory. We can see the permissions on the directory, the owner and group, modification time, etc. There are three different types of permissions. The permission to read, write, and execute, represented by R, W, and X respectively. The read permission lets users list what's inside the directory. Without it, they can't see the contents. Write permission allows users to modify the directory's contents, like adding or removing files. Without it, they can't make changes. Execute permission enables access to files within the directory, as long as users have permissions for those files. Without execute, they can't enter or use the directory at all. These permissions are key to managing your directories and securing your system. And there are three sets of these permissions for different types of users: owner of the directory, group, and others. So, this directory bin is readable, writable, and executable by the owner and the members of the group, but not writable by others. Let's quickly verify our access to the directory using ls-l. We are able to list the files in the directory and look at the information of the files. Note that the script hello.sh is not executable. What does that mean? We get a permission denied error when we try to run the script. We'll come back to changing the permissions of the script and making it executable a little later. Let's learn how to modify the bin directory's permissions using the chmod command. We remove the permissions to execute the directory from all the users. The letter A refers to all users, the minus sign indicates removal, and the X is for the execute permission. We can check our access again using ls-l. We are able to list the files in the directory, but unable to get more information on the files because we don't have execute permissions on the directory. We can restore the execute permissions to the directory alone by using chmod a+x. But let's use the recursive flag to chmod to make both bin and hello.sh executable in a single command. We have now restored execute permissions to the bin directory to all the users. At the same time, we have also made the hello.sh script executable. We can quickly verify the change. We are able to list the files in the directory and can also see that the hello.sh script is now executable. Let's execute the script hello.sh now that it is executable. Yay! The script is now executable, and it just outputs hello world to the terminal. We were able to change the permissions of the bin directory and the hello.sh script inside it using chmod with the -r flag. Applying permissions recursively is quite useful for managing permissions to files and directories in Linux. To learn more about permissions in Linux, you can also watch the tutorial Understanding Ownership and Permissions. Let's explore the sticky bit, a special permission in Linux. When the sticky bit, indicated by a T, is set on a directory, it restricts file deletion within that directory. Only the file's owner, the directory's owner, or a super user can delete or rename files. This is especially useful for directories like /temp, where users need to create and delete their own temporary files, but shouldn't modify others' files. Now let's delve into setGID or setGroupID, another special permission useful in collaborative settings. The collab directory here has the setGID flag set, indicated by the S character. Also note that the directory has been created with developers as the associate group, instead of Kavi, to help explain how the setGID flag works. The setGroupID flag would ensure that new files created within Collab would now be associated with the developers group, instead of the Kavi group. Let's check with a quick trial. We created a file in the Collab directory. Let's check the ownership of the file. Notice that the owner of the file is Kavi, while the group associated with the file is developers, not Kavi. How do we remove the setGroupID flag on Collab? We've removed the setGroupID flag using chmod and g-s, but we've also had to use the sudo command to become a super user. This step is necessary because unsetting the flag can change the ownership of files created in the future. We'll dive deeper into the sudo command and its significance in a future tutorial. Consider subscribing to stay tuned. Files now created in Collab will not automatically be owned by the developers group, but are owned by the Kavi group. And that's a wrap on directory permissions in Linux. We've covered viewing permissions with LSL, modifying them with chmod, and explored special permissions like StickyBit and setGID. Keep practicing these skills to enhance your Linux mastery.